Greetings, this is Eugene the Philosopher, the greatest living philosopher after the unfortunate passing of Quentin Robert de Nameland, who has been the greatest living philosopher before me. Let us talk about the concept of probability in this video. So basically what I'm going to do, or at least what I hope to do in the next, I don't know, half an hour maybe, or 20 or 40 minutes, who knows, depends on how much digressions there would be, that was a long sentence, is to add a little bit of skepticism, you know, in that sort of way to your agenda, if you haven't had enough already. So, okay, we'll try to poke a little bit this concept of probability, like statistics, and it's, of course, sort of a part of a larger campaign of mine, where I've talked about this before, that we need to seriously revise the concepts of probability, like statistics, thermodynamics, and logic. I would probably never address logic in my videos, although we'll see about that, but I plan to talk about thermodynamics sometime later. But today we're talking about statistics, and in particular probability, and you might say risks and things like that, like predictive power of probability, if you like, but probability in general. But this is, of course, only, again, a poke, an attempt. It's not like a complete description of the thing. I just want to bring to your attention some points that you probably haven't thought of, or I don't know, well, whatever. I just hope that you'll find this video interesting and the points therein. All right. So I'll start with a joke, which is sort of like a post-Soviet joke. At least it's in Russian originally. So I'm not sure if the context would be easily understood. So I'll give you some context. So in Russian, in like post-Soviet world, blonde girls are considered to be stupid, right? And there's a lot of jokes about this, like how blondes stupidly behave in certain situations, etc., etc. And this particular joke is about that in particular. So the joke goes like, a blonde was asked, like, what is the probability of you meeting a dinosaur on the street? The blonde thinks for a moment and says, well, 50%. And they ask, like, why? How did you calculate that? And she says, well, it's like I'm either gonna meet the dinosaur or I'm not gonna meet the dinosaur, right? 50-50. So this is the joke, and I would say that it pretty much sums up what I'm going to tell you about the probability, so of the future events at the very least. So even though it's a joke, I would say it's not funny at all. It's actually true. I mean, what is funny is the pretense of the probability theory on knowing something about the future, but we'll talk about this in a moment. So yeah, well, firstly you can ask, well, why would somebody ask a blonde such an interesting question? Well, maybe they tried to prove that blondes aren't stupid, right? Like, how could she calculate this probability in the first place? Or maybe they tried to prove that they're indeed stupid, so they asked this question. Well, that's a whole separate, you know, philosophical tree of questions that opens up right here. But anyway, we're not going to be concerned with this. But what I'm going to say is that this main point that is illustrated that by this joke that I'm going to make in this video, which is basically, spoiler alert, that the probability of any future events to occur is 50%, strictly speaking. This is my point, my main point in this video, but there's going to be much more of them, is taken from Mises's book. Ludwig von Mises, arguably one of the fathers of the modern Austrian school of economics, like in general, this libertarian type of thinking, a really, really smart guy. So out of all people, like, you wouldn't probably expect any economists making any contributions to like fundamental philosophical science, but I believe this point of Mises really like nails it. So in Human Action, Mises's book, he claims, and like I seriously was amazed by this point, and I think it's very, very true, which is this video is about. He claims that the probability basically only works with known data sets, right? Like if you, it's already my consideration. Like if you consider the origins of probability theory, it's gambling. And in gambling, you pretty much, like, if it's a card game, you know all the cards on the deck, right? So you can theoretically calculate possibilities, etc. Or you play dice, also you know all the possible outcomes, etc. So it's all very sort of clean and sterile environment, you know. So that's where it comes from, the probability theory. So we know all the possible outcomes right away, like a priori, as they say in Latin, before they experience, we've encountered them, right? So we have a right, in some sense at least, to assume that the new situation we're encountering also would be a part of this already known data set. Like if we are handled a card, we know what kind of cards are there in this deck, so we have a possibility to estimate by whatever means that it was one of those cards at the very least, right? So we can calculate some stuff based on that. So this is how probability works, is again, when we have some data set and we have the right to claim that the new event, new situation is a part of this old data set that we already know. So we've seen the deck of cards, we've handled the card, and we know it's from this deck, so we know it's one of those cards, right? Then we can calculate the rates of occurrence, etc., etc. So this is the point Mises makes, that probability works in this particular sterile environment when we know for sure that the new situation is part of the set of old situations, so to speak. So yeah. Then we can estimate probabilities, etc. And so in this perspective, now it's all my words, not Mises, even though he may have claimed the same things, I just don't remember because I've read Human Action like more than 5 years ago, maybe 7, something like that. So when we're talking about probabilities, calculating chances, etc., it's inherently what you may call inductive reasoning. Whereby inductive, I mean the classical logical method of induction, which means you have a particular case, a special case, from which you make general conclusions. So you generalize. This is induction. Deduction is the reverse process. When you have a general set of data, let's say, and you deduce from it the particular case, right? But induction is well, you have some situation and you generalize it on every possible case, or at least most cases possible, etc. So it's inductive reasoning, and I mean, we have a situation and we say, well, it's part of a larger set of situations that we already know, so it's induction. And inductive reasoning inherently is vulnerable to many flaws, and the main flaw is, of course, I would claim at least, is the so-called black swan. Now, if you don't know what it is, it's basically a situation when you have a claim like all swans are white, right? When we had the old world kind of thinking, but then people went to Australia and find out that, oh, you see, there are also black swans in Australia. So, and it broke the whole paradigm, you know, that it broke this statement, inductive in its nature statement, that all swans are white. This was like, we observe white swans, so we generalize to all swans, that they're all white. But then a counterexample appears, a black swan, so this statement is already not correct anymore, this generalized statement, right? So, and it's a general problem of this probability theory, that we ultimately claim that by observing certain particular cases, we claim that we have knowledge about all possible cases. And therefore, we conclude, we can attribute, or we can connect any new situation to any already known set of situations, right? Or the already known set of situations. Any was a wrong word here, right? So yeah, so basically this inductive reasoning is wrong. we claim that we've seen all the cards, therefore this card is one of those cards that we've seen, but maybe it's some new card. That would be a black swan type of situation, right? Like 11 of some things, 11 of spades or whatever. We haven't seen this card, but, well, who knows? Maybe we've been handled it just now. So this is a black swan type of situation. So in returning to my old epistemological, gnoseological videos like Nature of Knowledge and whatever, like pseudoscience and scientific pyramids and blah, blah, blah. There have been many of those where I talked about that the nature of knowledge, basically. So, and how the science is, the main purpose of science is constructing objects. So in this case, we can say that our object, which is our old data set and the new situation, is poorly constructed in the case of this black swan situation. So, we have poorly constrained the conditions. So, roughly speaking, the walls of our narrative crumble and kind of chaos pours in. Like, we really didn't expect 11 of spades to appear, but it did. So it kind of ruined our whole narrative, and we're like, oh, what's going on, guys? Like, this type of situation. So the object wasn't solid enough. Again, speaking about Bruno Latour's theory of science, etc., etc. All right, and so basically what I was talking about in the last, 7 minutes is that this probability theory inherently is based on inductive reasoning, which is vulnerable to black swan type of situations. Inherently, again. So you cannot deny that in any way, shape, or form. Another flaw that we have in this probability type of thinking is that, well, if you think about it, like, what is the probability of the current moment in time? Like, if you imagine, as these kinds of people who believe in probability theory sometimes do, in a random universe, where just particles move chaotically or by some whatever kind of law, but still in probability type of matter, quantum mechanics, etc., then you would come to a conclusion almost immediately, I would say, that the present moment in time with this particular arrangement of particles is impossible. Like, the probability of all the particles in the universe being arranged exactly they are arranged right now is 0. Like, I mean, it should be pretty clear. Like, I mean, your body has like 10 to the 26th maybe or something particles, like electrons, protons, and whatnot. And each of those particles have, well, let's say they even have 99% probability that they are in this particular state as they are right now. Well, still, 0.99 to the power of 1026, if you multiply all those probabilities, it's basically 0. So the present moment in time in a random universe is impossible. Like, random universe would never possibly form anything like the present moment, with all the particles involved being in those particular places where they are. I mean, I've talked only about your body, but it's basically all the universe, right? So all the universe should have had arranged by some weird chance in this particular way, right? According to probability theory, if everything is completely random, right? So it's impossible. So, and I think it's a very strong argument against the whole probability theory that, you see, a theory which describes the clearly observable present moment in time that we're all in right now, that describes it as impossible is a stupid theory. It's a bad theory, right? Because, well, it in some way it's kind of self-falsifying, Like, whatever you observe, whatever the state of the universe you observe, the probability theory would say the probability of this particular setup of the universe is 0, so it shouldn't happen. So, like, it's perpetually self-falsifying, if you know what I mean. So, I haven't heard anyone really make this point. So, I think it's really important to understand that this is really the case, right? So no kind of absolutization of probability theory is justified, I would claim, because you can clearly see to which contradictions it leads, right? Then we have problems such as extinction events, for example. Like if you've studied ecology, like populational dynamics, you probably heard, or paleontology again. Of course, it's all, I mean, based on all those datings, etc. But still, it's pretty much an established thing in this area of knowledge, let's say, that extinction events are not really susceptible to regular statistics, so to speak, and to like normal probability distributions. And what I mean by that is, well, I don't want to go too technical here, plus I don't really know much about this, but what I definitely know is that roughly speaking, well, technically speaking, those extinction events, let's say, when you try to estimate the time of extinction of a population, these distributions of those times have what they call fat tails, or like high tails. Like on a very intuitive level, you expect like this Gaussian bell curve, so you have a high probability with like somewhere in the middle, and these rare events would have low probability. But in extinction events, you have a higher probability of higher occurrence of low probability events, basically. So roughly speaking, rare events somehow in this extinction dynamics happen much more frequently than you would expect, again, basing on the standard normalized whatever kind of statistics, right? So basically, again, very roughly speaking, and quite incorrectly, but still maybe it would help speaking, extinctions kill much more species than they should. So species die out in rare, but on the other hand, not so rare mass extinction events, rather than just naturally, statistically kind of dying out. And if you think somehow that this is the evidence for some sort of or something, I should claim that by the same token, what I've said before about the inductive character of probability type of statements, if you claim, let's say, that we have cycles of extinction, well, I have bad news for you, because you can deconstruct the same notion, the same statement about cycles based on the same idea about the internal incoherence of this probability theory. You see, the statement, let's say, about the existence of cycles is also an inductive statement. So we observe that, okay, today it's something. Okay, like 11 years after, if we're talking about the solar cycle, let's say, it's something similar. So it's like 11 more years after, it's something similar as well. So we assume that, okay, there's 11-year cycle. So, and we generalize, again, we observe anecdotal evidence, so to speak, and we make generalized conclusion that it should be the case that there is an 11-year cycle. So it's a general cycle, it's eternal, basically, right? So this is an inductive statement. We observe these cycles and we claim that they're general, they happen always. But this is not the case. Again, any black swan might break this sequence. Like sometimes you observe that the cycle breaks, and wow, like what are we gonna do with this? Like we don't know. Like statistics just doesn't work with these situations. That's what I'm saying, because again, we've assumed that we have a data set which is representative of eternity fundamentally. So we assume that these cycles would exist forever, and now suddenly the cycle breaks, and what are we going to do? Like, we have no idea, right? But probability theory states that, yeah, the cycle should continue. I mean, not probability theory, but this inductive statement that we've made about cycles in the first place. So if we have cycles of extinction, let's say, nobody can possibly guarantee that they are eternal. Like, again, the cycle might break. It would be a black swan situation, but It would just deny our initial inductive statement. But it's okay. I mean, who knows what's going to happen, right? Like, you might claim that, again, according to this methodology, so to speak, of cyclicism of everything, that, oh, things would be the same as before always. Well, no, things aren't the way they were before. You wouldn't even recognize me anymore. Not that, but you knew me back then, but it all comes back to me. And there was a 50% probability that you also saying the latter part. Okay. So yeah, things would be the same as before. It's the inductive statement from the standpoint of the cycles should continue, etc. But no, I would claim, because every moment in time is different from the previous moment in time. And it's really easy to logically prove, because, well, it's actually a tautology, if you can notice this. Again, see my video, Logical Cosmology, where I give the general framework of this logical approach to things. But anyway, now is different from before, because if they were the same, we wouldn't be able to distinguish between before and now. It's pretty clear, I think. So something changed, right? At least something changed that allows us to say that this is now and that was before, right? Otherwise, we wouldn't be able to distinguish them if everything would be the same, if everything would be cyclic, etc. So, yeah. And it's kind of the generalization, or rather extension of the same point I made in my video, Stories of Medicine, where I talked about that. Again, I've also touched on the topic of probability, that like medicine operates with statistics, etc. But there are no two same people, you know, two human beings which would be identical. Even twins aren't identical, obviously, because, well, we can distinguish them. And the same goes, it's not only people, it's also any object. Like, if you produce two same steel balls, like, they would be absolutely identical in terms of mass, electric charge, like whatever, you still can distinguish between them, right? One ball is here and the other is here, so at least something is different about them, right? So they're already different. They're not the same steel ball, because otherwise they would, you know, coincide, and we would perceive them as a single steel ball in the first place. So yeah. So already in this case, like, in the very fundamental sense, statistics and probability theory fails, because these are not the same steel ball. Even though there's a principle of, I don't know what's the proper phrase in English, but basically that states that all the elementary particles in the universe, all this same type of elementary particles are indistinguishable, right? So two electrons, you cannot distinguish between two different electrons. They look as the same to you, etc. And there's an interesting theory of, like, one electron universe, stated by Feynman. But anyway, it's a long digression. All right, so why do we do that? Like, why do we need probability theory in the first place? Well, I would claim that mostly it's due to this existential aspect. Like, we as human beings, we have this gaping abyss of unknown, right? And we need to patch it somehow, like cover it with something. So probability, I've already talked about this in one of my videos, though I don't remember which one, but the situation is similar here. Like, we need to patch it with something, like cover it with some dirty rag, which is probability theory in this case. So we just say, okay, we don't know what happens in the future, but at least we might assume it would be somewhat similar to what happens in the past, and we have a lot of data on what happens in the past, so probably it would be something of this old data set that's going to happen in the future, right? This is basically the basic statement of the probability theory. Like, choose something that already have been and you'll get the future. We just have to properly calculate how probable it would be, and like, then we can gauge how sure we are that the future would be exactly like that and not like that, but at least we have knowledge of the whole array of possibilities, which again is not true on at the very fundamental level. Like again, black swans deny this whole statement right away, but this is the idea of probability theory. That again, existentially, we need to fight the unknown somehow. We need to introduce stability in our lives, etc. So we use probability as this sort of crutch to deal with the unknown. Fundamentally, that's what we're doing. And in a more narrow sense, in physics, when people deal with probabilities, it's basically their attempt. Again, in quantum mechanics is a perfect example. It's basically the attempt of people to tame the how do you say it? Like indeterminism, I guess. So we don't know where the electron is really, but we say, oh, it's probably here. Like 99% probability that it's in this small volume of space. Of course, there's 1% probability that it can be anywhere else in the universe, but we kind of disregard that. Okay, we're pretty sure it's somewhere here, right? Even though it can be like a million light years away. Just as well, but it's only 1%, so who cares? Something like that, right? So it's an attempt to bring some sort of order into this chaos, inherent chaos of the future and of the unknown in general. And speaking about chaos, I wish to introduce sort of to balance the weight, or how do you call it, Libra, which is myself, with another concept. Again, we talked about probability, which is sort of this attempt at attaining stability and sureness, so to speak. And the other pole is possibility. That's why this video is called Probability and Possibility. So possibility is a much more dangerous concept, yet it's a much broader concept. It doesn't require as much limitations as possibility does. Again, possibility is based on a very specific inductive statement and very specific knowledge about the previous events, etc. Whereas possibility is open to everything fundamentally. You just say, well, it's possible. I don't know if it's probable, it's just possible. I don't know if it's going to happen or not, but it can happen, so it's possible, right? That's what I'm talking about. So because of that, it's sort of like a more frightening concept, right? Because, well, strictly speaking, anything is possible, right? A guy might just fly and like lift up into the sky. It's possible. I mean, who knows? Like really, maybe it would be one of those black swan type of situations. Like maybe he invented some sort of magic or unknown science or whatever that allowed him to fly. Like, why not? I mean, like, I see no limitations of fundamental sort on this sort of thing, right? And it's, by the way, telling when you look at history of ideas that, again, Thomson said that machines that are heavier than air would never fly and blah, blah, blah. And, well, you know, it's probably, it's quite famous, all those lists of stupid predictions, etc., like unfulfilled predictions. So it's one of those things. Again, all those black swans are entirely possible. So there is a concept of probability, which is about stability, and there's concept of possibility, which is kind of about chaos, because it's not limited to anything, right? And it's more frightening because of that, because who knows what's going to happen to you in particular. So you might die right now. It's possible, but it's kind of scary, right? Like probability theory would say, it's probability is like 0.001% that you're going to die right now. So relax. But possibility says, well, it's possible. So you should be kind of afraid. But at the same time, it's only one pole of this possibility tree. And another pole is actually, it's more inspiring, because probability might say, well, it's very improbable. It's almost zero probability. But possibility says it's possible, so go for it, you know. Try to achieve it. So, like, I don't know, like, whatever, like, take the shot. I mean, it's highly improbable, but you can still win. I mean, there's a possibility, at least theoretically. in the most general sense. So yeah, so in some sense it kind of divides people into those who are more afraid of a possibility and who are more inspired by the possibility, right? More stable oriented people and more chaotic oriented people, so to speak. And I believe it's inherently connected, this concept of possibility, with will to power. Again, a concept I've discussed many times, Nietzschean concept, of course. It's connected to the idea of intent, like you wish something to be true, and you see a possibility, therefore you kind of, go for it. It has a directionality to it, so to speak, taking the shot again. So I would claim even that perhaps this will to power and its inherent presence in all the life forms. Again, see my video, Onion of Aliens. I've talked about this quite a lot there. 3 videos, actually. So where I talk about life, intelligence, and all those kinds of things. So perhaps will to power is actually what makes rare events much more frequent in those living type of systems like populations, etc. So because they have will to power, so they have directionality to their development. They are going somewhere. They have the goal, which is, again, returning to Onion of Aliens, is the goal is to repeat in time and multiply in space, right? At the very least, and that's like a conservative estimate of what's going on. So yeah, maybe living systems demonstrate this improbable statistics exactly because, well, they're oriented on possibility rather than probability. So they are inherently improbable themselves, living systems. I mean, speaking about entropy, negentropy, how living systems actually export entropy, whereas dead things are entropic inherently. And there was I think I've quoted him in Onion of Aliens, but I'm not sure. But there was a theoretical biologist, which is in itself a very interesting thing, Erwin Bauer, who lived in the Soviet Union. He's from Hungary originally, but he described living systems as systems that are in a stable inequilibrium, what he called. Or stable non-equilibrium. So, in natural, like dead, physical, mechanical, you might say, systems, there is a stable equilibrium and unstable equilibrium. And there's obviously unstable non-equilibrium. But living systems are stable non-equilibrium, right? So they are like, everything tends to, fall into the potential wells and whatever, but living systems kind of intentionally crawl out of the potential wells and maintain their organization despite all the dissipating forces, right? So that this is the stable non-equilibrium. Whatever. Anyway, there is intent in living systems. There is will to power. There is directionality. And again, arguably it's connected to the arrow of time in the first place and blah, blah, blah. But I don't want to go into too much detail. We're talking about probability specifically here, right? So we have those 2 poles to sum this section up. The pole of probability, which claims that this new situation, or the situation which is going to occur tomorrow, let's say, would be one of the situations we've already observed. This our stable data set of old situations. So it's gonna be nothing new, and therefore we can calculate the probability of this just judging by how big is the chance that randomly picking one of the old situations, we're gonna end up with this particular one, right? This is what probability states. Whereas possibility, and this is stability, right? Like equilibrium, you might say. Whereas possibility claims that, well, everything is chaotic in some sense and unstable, and new situation might ruin any sort of old narratives we've had previously, right? So something new happens constantly. This is the standpoint of possibility concept, basically, right? So we have this order against chaos, probability against possibility, determinism, you might say, versus indeterminism. All right, so we're going closer moving closer to the conclusions. And there's just one major point I wish to make before we go into conclusions. And this is a thing you can frequently hear from, let's say, creationists or people, adepts of Entropic Principle, which basically states, again, I've described it in onion of valence in some more detail, so I'll just briefly mention that. It basically claims that I'll make a strong entropic principle because, again, as I've shown previously in onion of valence, weak entropic principle is just a tautology, so it's useless. So strong entropic principle claims that the universe is the way we observe it because if it was different, we, as we are today, wouldn't exist, right? So the universe, in some sense, paraphrasing, is there for us to exist as we are, right? This is the entropic principle. And creationism basically says that everything is made by intelligent design of some super knowledgeable creatures such as God and whatnot. And they're very similar in this respect, right? So everything happens for a reason in some sense. This is their common ground. And the reason is whatever. Both of these things, both creationism and entropic principle, also contradict, you might say, this probability type of approach, right? Probability theory. Because they say, they focus on these, again, living things, and in particular, well, as I've said previously, living things are kind of manifestation of improbability, right? So they shouldn't really exist, at least the way they are. So why do they exist? This is the question that creationists and anthropocentric people ask about all the world, or at least human beings. So they explain it by design in the case of creationists, or well, almost like a miracle from entropic principles perspective. But I would claim that both of those explanations are sort of, I don't know, like how to segue into this. I guess let me give you my vision of at least entropic principle and creationism, by the way, too. Like, what is my answer to this? Like, I'm not a creationist. I'm not an adept of entropic principle. So my stance on how do improbable situations like the one we observe happen, right? Well, my answer is that they happen because, again, living things have will to power. So at least living things. You might argue, although it's very hard, that dead things also have something like that, but again, it's a very hard discussion. Like I've made some research into this when I was like, I don't know, 15 years old, 16, 17. I've tried to like reformulate physics in the language of will to power, and I kind of failed. So I don't think it's at least there seem to be no easy ways to do that. But who knows? I mean, maybe it's possible, but whatever. So my point would be, at least with respect to living things, with which at least the creationists and anthropic principles, so to speak, are the most concerned. So my answer to this would be that living things adapt, right? They have this will to power, the desire to climb the metaphorical ladder, whatever it is. So they try to, again, repeat in time and multiply in space. So they try to fill all the possible niches that exist there, right? So roughly speaking, we set, let's just imagine an abstract world where we set the laws of physics. We imagine that we forget about that the laws of physics is a constructed concept made by human beings. We just naively assume that physics is like the foundation of everything. So we assume that, okay, we set some physical laws, chemical blah, blah, blah laws in place, and then we throw living stuff into it. Again, it's a difficult question how living stuff appeared in the first place, blah, blah, blah. Again, see my video on onion of valence. But living stuff tries to replicate, repeat in time, and multiply in space. So this living stuff tries to, again, adapt to the laws that are already there, right? So it's already embedded in those laws fundamentally. So it develops itself in such forms in order to expand its will to power as to be, like, it develops according to the laws that already exist. So in the end, you get human beings and whatever other living beings that you get because the laws are the one we have. So again, in some sense it's a tautology, but to claim that the laws of physics are such so that the human beings would be as such as they are is this kind of crooked, like backwards logic to me. Like, to me it looks vice versa, like the human beings are the way they are because they've evolved, like expanded, blah blah blah, will to power, in those conditions with those laws of physics. Like, if you adjust the laws of physics a little bit, let's say, well, again, Entropic Principle, people would say, well, humans wouldn't exist. What I would claim is that something else would exist, something different. Of course, it wouldn't be humans as we know them today, but something different, but something alive would still exist, and perhaps it would also be intelligent and whatnot. So this is my stance. It's basically, yeah. So I think it's a logical mistake that they're making, like a logical error. That again, well, I've already described it many times, so I'll stop here. So a metaphor you might consider in this case is that there's a difference of this top-down approach of creationists and Entropic Principalists, which says, well, okay, I'll give you a metaphor. So one metaphor is my metaphor, which is, again, will to power, evolution, like repetition and multiplication, which says that this part of the metaphor is like, imagine we have a vessel, like a glass vessel or something, with a very complicated form, like it's very weird, and we put some gas under pressure or liquid under pressure into it. What's going to happen? It's going to fill the vessel, right? And then we like cool it down or whatever, so it solidifies. And then we remove the vessel. What's going to happen? Well, we would observe this weird form, right? Another analogy is their analogy, this creationists and Entropic Principalists or whatever, is where you have a solid block of stuff, of the same kind of stuff that we have previously, but it's solid right away. And intelligent design or a miracle or chance carves out of this solid this same shape, right? So these are two different approaches to what we're observing. Like, why are human beings the way they are? I'm explaining it with those preset physical laws, roughly speaking. Again, you can deconstruct this statement, but naively speaking, we have preset physical laws represented by this glass vessel, which are filled with this will to power, like this vis vitalis, as they said in Latin, like living force. So this living force tries to fill all the voids according to these preset laws of physics, which are represented by this vessel, and we get what we get, right? As weird as it is, whatever. Whereas the adepts of this intelligent design or Entropic Principle, they claim, well, something kind of have fitted the laws of physics to the human beings as we know them. So something carved out of this pre-existing randomness, which is this solid, which doesn't have any form. It might be completely amorphous, but something, some mysterious force have carved this weird shape out of it that we observe. So, and I think my approach is, I mean, it sounds kind of arrogant, but I think it's much more reasonable. Like, again, whatever. It's your, it's up to you to decide which is more reasonable. I at least hope I was able to describe my position in more or less enough detail. All right, so let's go to the conclusion. So what was I talking about in this video? Well, I tried to deconstruct, at least, again, poke a little bit, like, how do you say, chunk some pieces out of this established concept of probability. and probability theory, etc., etc. And my main point, again, comes from Mises, Ludwig von Mises, is that, well, he actually doesn't say that. It's kind of my own reflection upon it. What Mises says is that in order for us to talk about probability, we have to have a knowledge about all the possible set of all the events that can happen. And we inherently cannot have this knowledge because future is unwritten, so to speak, to quote the title of the movie about Joe Strummer. So, therefore, this joke about this blonde girl who says that the probability of her meeting a dinosaur on the street is 50% is not so funny, actually. It's very, very true in some fundamental sense, because we don't know what's going to happen like a day after. It would be something inherently new. It's not part of our established data set of what happened, what has happened. Again, it's very easy to logically prove that, because tomorrow haven't happened yet, because otherwise we wouldn't even identify it as tomorrow. It would be something already known. And, well, I've already gave you those examples with the steel ball and an arrow of time and blah, blah, blah. So the main point is that the probability of future events cannot be estimated at all. So any event in the future has 50% probability to occur. This is my main point in this video, probably. Even though, kind of digressing a little bit, you might claim that, well, in order to even identify something that has occurred or has not occurred, you already have to adjust your optics, so to speak, to focus on this, because, well, roughly speaking, every moment in time has infinite amount of possible interpretations, because, well, hopefully it's understood. So you can equally claim that something happened and something didn't happen, depending on your optics. So you have to adjust, but okay, that might be too hardcore. So let me stop here. Let me just reiterate that I've talked about this in my video Nature of Knowledge, where I talk about that the knowledge is a bunch of stories, and the stories of history, where I talk about that in order to tell a story, you need a proper optics, so to speak. You need to focus on those actors and the narrative that's happening in between them. Otherwise, you wouldn't see them. So in order, kind of generalizing to the point I'm making here, in order to conclude that something has happened or hasn't happened, you need to adjust your optics, right? Because you might equally viably claim that something happened or didn't, with the very same set of observations. That depends on you. But again, I'm really sorry. It should have been conclusions which should have been really clear. Okay, main point. Probability of future events is unknown, or actually it's 50-50 always, just because future events have never happened yet, whereas probability theory requires new events to be part of the old set of events. Basically, that's the main point of this video. And yeah, and otherwise, what I propose here as an alternative is the concept of possibility, which doesn't require anything at all. It's just very open and very skeptical, in the sense that it doesn't know what's going to happen, right? So this almost opposite pole with respect to probability of possibility says that, like, chaos of possibility versus order of probability. So this chaos is almost like a free highway, let's say, both frightening because anything can happen, including all the worst things, and inspiring because anything can happen, including all of the cool things, all of the miraculous and amazing things. All right. Thank you for watching. The eons are closing.